agendas are in your packet for how we're going to flow through the day. And with that, I think we are going to head and get started. I do want to mention our advisory board has been instrumental in helping us find the content, comb the content, identify the biggest priorities for this event. And they've been instrumental in picking our research projects over the years. So I do want to call out all of our advisory boards, not only the current advisory board, but our past advisory board members. So if you're a past or current advisory board member, will you please stand? Thank you. All right, 8:45. You'll learn from me that we're going to keep our 2 days on time. We have a lot to get through, so we're going to go ahead and get started. You won't be hearing from me over the course of the 2 days entirely. Our board members are going to take an active role in both presenting and moderating. And so it's my honor to introduce one of our very first board members, helped us form the council and has been with us ever since. Close colleague, great expert of himself, working in stormwater and certainly in ponds. So he will get us off and started on our first topic this morning, Understanding Ponds 101. Ross Bittner from the City of Edina.
Hey y'all. John asked me to say a couple words about the board as I make the transition over here to, oh, I don't have the slide up, so Todd, if you can come help me get the slide deck up. As a board member, we have rich discussions at the board, really talking about the needs of the implementing community, the new science and how it might affect the tools and the development of those tools. And a key part of the funding that's coming through from the Clean Water Land and Legacy Amendment is really about technology transfer. And to me, technology transfer is about getting the practices that are coming out of the university, that new science, into this ecosystem of professionals and quickly figuring out how we can make the next best step with that key information. So to kick off ponds as a practice in Minnesota, I wanted to kind of come back to that theme and that purpose from the advisory board, and kind of this conference is really about bringing some of that energy out to the people we serve, you, and involving you in that conversation so that we can make that technology transfer and technology development process continually happen faster and really get the value right out there where we're working. So the panel here or the group that you're going to be talking about are me, Todd Smith with the PCA, and David Filipiak, retired but former consulting engineer with SRF. When we got together and said, why us? We looked at all our gray hairs and wrinkled faces, and we said, it's clearly because we have, and we're willing to admit this, more than 20 years of experience individually. So we're going to have a lot of young professionals coming up and researchers, but for now, let's set the context of the types of ponds in Minnesota, their extent, use, and history, truths, and myths. So I'm going to say that historical framework for ponds and for any individual pond is very important when you're thinking about ponds in general. I'm going to present to you some idealized cases about ponds that we see out in Minnesota today and how we manage them, but know that there are as many contexts for ponds as there are ponds on the landscape. When you think about your individual ponds and the ponds that you connect with the most, think about the history of the development. Why they were developed there in the first place. What was the landscape before there was a pond there? These things are the leading edge of development when we bring, a city to a place that didn't have one before. Whether it was agriculture and the varying types of agriculture that it could be, the historical land use. And that point of land development really is, tells you a lot about the pond. And it has changed over time, which I'll make more clear here soon. For a long time, our purpose was just to mitigate. So when we developed a landscape, we were quickly speeding the waters onto the surface waters. Ponds were just one little mitigative step to try to make it no worse than it was before. We're starting to change that. We're starting to see more of a restoration purpose. And that pond technology and what we're asking from ponds and all the suite of BMPs that we're putting in place on the landscape today, that really is that service level definition that we're working for. And it's going to vary over time by the era of construction. So to help bring our new AI tools into the mix, I made a notebook with all of the historic best practices for ponds. We're going to hear a little bit about NERP from our other presenters today. NERP was maybe the Bible of stormwater for a while when it first came out. There was continual efforts as we went to continue to target and select BMPs, to ask them to do more, to standardize our designs based on best practices and lesson learned, and then crowdsource it with the current stormwater manual and wiki to bring more minds to bear on these practices. So while we know that NERP isn't a set of standards or something that's written in stone, it was an important early document, and as well as many of these EPA and MPCA documents, just to try to get a flavor for how this has changed over time and what kind of our highest level regulatory requirements, what they've called for. I asked the LLM, what does the model say? Or what does the manual say for things like pond sizing? And you can see, pick your favorite, whether it's the design volume or the purpose for peak rate, whether it's the geometry of the pond or individual elements of the pond for safety. You can see through each one of these eras in the 80s, 90s, aughts, and 2010s, the increasing standards coming up. The size of the ponds increasing, the complexity of their designs increasing. What does the manual say for purpose? Here we see very simplistic start where it's sediment and all the adsorbed pollutants like metals, and a little bit for rate control, try to slow that water down. The rate and flood purposes in the 90s and the 2000s really increase. We're asking a lot more. We're thinking more about flooding, clean water purposes. We're starting to think about some of the internal dynamics of the ponds. The current stormwater manual is really taking science, as it's happening. I was involved in one of those with Andy Erickson in the pond bench filtration in the early 2010s. And bookmark this. We're going to come back to this discussion a little bit more. But this context of how the regulations change, this is really this isn't the leading edge. This is the consensus. When it makes it into regulations, we're at the consensus point. But when we think about that overall technology and practice evolving, adding more, going from just a mitigative purpose to more of a restoration purpose, we're asking more, and we're continually going through this process where science informs our design, we build it, then we monitor it, and we learn we need something new. We need to craft it again. And this is technology transfer. This is the process that we're going with. But when I look back, these are high-level technology transfer, the decisions that we're making to actually change the rules. They're happening at federal agencies or maybe the state agencies with some high-level university or practitioner connections. This conference is really about speeding that process up and bringing a lot more voices in so that we can make this technology transfer process happen quickly. figure out what the next best aim shoot is in this continual process. So I'm going to go through and set a little bit more framework here now. Thinking about this now from those different practitioner, academic, and policymaker standpoints, let's look at how some of those regulations, the context of individual ponds during their eras of development, and the design goals as they changed really affect us, the practice that we look at, and in general, the state of the practice today. So I start with the one that we're all focused on because we have a regulatory requirement, and this is a very information-dense slide. I know that, and I'm going to give you some time with it, but I also made a poster on it. So if an idea here strikes you and I don't give you enough time to look at it, you can always come by and we can chat about that pond that you're thinking about and how it might fit in. So this first one's really about that orange slice there on the bottom. A key note is, generally when we have MS4, within the MS4, that's all constructed infrastructure, that's stormwater infrastructure. That doesn't overlap with natural water bodies and receiving waters. We like to keep those two types of ponds separate. Now the literature and the science has a lot of intermixing of these two types of ponds I'm going to talk about, but the stormwater ponds are designed and constructed today in uplands. They have gone through the legal process to replace a wetland if they're in portions of wetlands. We have easy exemption to get in and maintain them through the Wetland Conservation Act. In fact, when I was a WACA authority, I didn't even go through the process because I knew that nobody was going to come and call me on that. But it's easy to maintain a stormwater pond because it's clear, it has a design, a stormwater management plan, and it had a specific purpose. So I can quickly modify it, restore it, retrofit it, and get it onto its next life cycle. Here are some of the things that you see in a typical stormwater pond. That safety bench, the normal water elevation, usually a very complex outlet for those flood and channel bank goals. Depending on when it was built and when it was last maintained, there might be 0 to 30 years, maybe design life of sediment in the mix. And we can get in there, maintain it. The modern ones have good access. So what's a pond in general? And now looking at the red part of that same Venn diagram, these are usually wetlands. And when those development points happen, we're often connecting in the wetlands and using them as well for flood storage. A lot of times we did that based on a sensitivity of the wetland. The higher quality wetlands we used a lot less. The lower quality wetlands we might have poured a whole lot of water into. They might look almost like your stormwater ponds, maybe a little less mass graded. These are natural water bodies or receiving water bodies. You can still get in there and manage them for benefits. Don't call it maintenance though. You can do work. You can make them an asset for public benefits. We can choose to manage these ponds. Sometimes they're partially in uplands, but mostly they're in low areas, natural areas. They still class out as wetlands. Some are more open water. Depending on the amount of sedimentation that they have, they could be type 1, 2, 3, or type 1, 2 wetlands. They could have ages of historic sediment. Determining how much you're going to take out when you choose to get into these is a little bit more difficult. They're going to be potentially providing some of that flooding and clean water benefit. But here we start to see some of that reflecting nutrients and maybe lack of maintenance causing a lot of juicy sediments that are putting phosphorus out into the water column. A lot more of that from the professionals later in the day and tomorrow. So what can you do with a natural pond? These can be used for phosphorus sediment sequestration, try to really work on the clean water benefits of the pond itself for the good of that pond. but then for the potential that it has for downstream systems and for maybe higher priority lakes or other water bodies. When we manage these for the positive benefit, we don't call it treatment. Treatment doesn't happen in receiving waters. So when you think about maybe these two idealized ponds and the changes that a modern pond versus one that we're just tinkering with a portion of wetland or Mother Nature, where do we see them? We see a lot of them in the second and third ring suburbs. Here on the Met Council map, we would call that maybe the suburban edge or the suburban areas. My experience comes from both Prior Lake and Edina, and I can say in Prior Lake there was hundreds of ponds, stormwater ponds, that were clearly stormwater ponds. In Edina, I think I found 8, but usually it's a discovery and a revelation when I find one. Wow, there's a grading plan and a stormwater plan for this. The developing fringe now, we're probably seeing a little bit less, and more on that with the change that Todd and David will describe. When we look back in NERP, a lot of the mechanics or the mechanistic removal things are well described way back in 1983, things that we're still thinking about today. We care a lot about how much we can get in there, how long the retention happens, the precip, evaporation, and infiltration. The overall mass balance of water can really matter for the mass balance of phosphorus. That suspension, resuspension, dissolution idea, and the biological stabilization, that line, we're seeing a lot more interest in, really trying to lock down and get more of that dissolved phosphorus and the long-term retention of that phosphorus. Artificial drawdown and cleaning, my goodness. That sounds a lot like adaptive level controls and some of the newest technologies for ponds. Way back in 1983. So let's zoom out now to the watershed scale. Let's think about these in terms of a framework for taking it from that project level approach, where we're thinking about just a single pond, and how it fits with its watershed. Because if our rules and our projects don't add together in terms of a treatment train that actually works, that's what the public's paying for. They're paying for systems level performance. So we've got to think about these things not in terms of projects, but in terms of systems. How do they work together? Important part of that is understanding what's coming into a pond and how that will change. Think about a pond that was developed in a mass graded area. 30 years from then, now we see a tree canopied area. Even what's coming to that pond is different than when it first developed. So its first life cycle, it's going to see a whole change in the watershed. You're going to see a lot more gross solids and organics coming in as those trees canopy out. A lot of tree connections in our research that you're going to learn more about, and their connection to that gross solids piece, the dissolved phosphorus piece. Ponds are really good at this orange zone. Some of the stuff that when we think about TSS, what can actually make it into an ISCO filter, there's portions of that water quality piece that we're thinking about that, and this is John Chapman's work. He might talk about that when he's on stage. They can get a lot. They're superstars when it comes to this gross solids and sand piece. Now think about in terms of all the way from the source to the conveyance to the treatment. This was a presentation similar to the last slide from 2011 when I was working with Andy Erickson on the iron sand filter benches. We conceptualized some of the mass flux of a pollutant, whether it's sediment or phosphorus, through a watershed, and really starting to try to figure out how we can pinpoint some of those major points of flux. And we were really drawing a line under that dissolve question. The dissolve, we're seeing a lot more of it coming out of the gross bed load. With recent work, we're really seeing a groundwater connection. More on that later as well. So let's think about now the treatment train. If we were to zoom out and design a pond today with what we know, and if this group was to come out with how to do the best on a systems level, what might it look like? So this is an example of that same nutrient sediment size piece, and then we street sweep. So that's in blue. 100% removal is not possible, but we're getting a lot of material out in the higher size fractions. Then we had a pond. Or maybe we don't street sweep and the pond gets to take on all of the load from the street that the street sweeper would have got. But still, we got a good amount of material out. We're starting to get into some of the smaller particle sizes. Click again. And now we've potentially thought about maybe some filtration applications. I know my local watershed when I was in Prior Lake was putting these things in long before filter benches and iron sand filter benches were a thing, seeking to lower the ground or the water of the pond slowly to leave a little bit more of that active storage. And then the iron sand filter, we thought could get a lot more of that adsorb piece. Depending on the size of the pond, you can see your way to getting to high levels of removal for total phosphorus, very high levels of removal for total suspended solids. So I present this as kind of a cross-cut now of how to think about ponds in terms of when it was developed, when the time and the context set yourself up for what that pond is going to see in terms of watershed load, and how it might work in a system. So now, to fill out some of the regulatory side of this question, we're going to have Todd Smith, PCA, come up.
All right.
All right.
Yeah, thanks, Ross. I think so. Great, thanks, Ross. Thanks for having me here today. I'm Todd Smith with the Minnesota Pollution Control Agency. I have been there for a little over 20 years. Today I was going to talk a little bit about some of the history of the pond regulations we've had here in Minnesota and how we got to where we are today with what it is that we require. So in 1972, under President Nixon, the Federal Clean Water Act was passed. This gave rise to the NPDES program, which has been our overall governing federal program that has directed us in stormwater since then. At first, there was a focus on industry and wastewater. It really wasn't until the 80s when we did the NERP study, the EPA did the NERP study, as Ross was telling you. It really was the first comprehensive data that we had on stormwater pond performance, and it was pretty revolutionary. They learned a lot. Another big piece of the NERP study is that they just really identified the problem. They took a look at what was in urban stormwater runoff and the event mean concentrations of all the different pollutants, and really identified it as a problem. And went a little bit further to even identify the extent that the urban runoff is a significant contributor to water quality problems that we have across the nation. And it turns out that it is a significant contributor. And as the other NPDES programs were in effect, and some of those pipes that were coming straight out of the factories were now having pollution control devices on them, urban stormwater runoff is now the biggest contributor to our water quality problems, at least in the developed urbanized area of the land here. So the NERP study gave rise to the 1987 Clean Water Act amendments, and this is when stormwater came into focus and launched all of our stormwater programs, both the MS4 program, construction stormwater, and the industrial stormwater program. It wasn't until 1990 that there was actually a permit for construction activity, which is where we have our pond requirements. They had started regulating all construction sites that disturbed 5 acres or more. That was considered phase 1. Their plan was a 10-year plan to move to phase 2, where they would lower that threshold down to 1 acre, which is where we are today. So that all happened in 1990. They had a permit at the federal level in 1990. And that is also when they authorized the states to administer this program. So across our nation, almost all the states have a stormwater program like we do here in Minnesota. There are a few states that don't have their NPDES authority for construction stormwater.
You still need to get a permit in those areas, but you need to do that through the EPA. So they had their permit, and we had our first permit issued here in Minnesota in 1993. And the Phase 2 permit at the federal level was completed in 2000, and that was in place here in Minnesota in 2003. So in our construction stormwater permit, we have a requirement. If you're going to create new impervious surfaces as a result of your project, you need to provide stormwater management. And I just wanted to take a minute to explain how that came to be, because it is a little bit different than the federal permit. The federal rules, and this is what's required of all the states in their permits, is that they have these erosion prevention practices on disturbed soils. You're required to have sediment controls at your perimeter of your site, inlet protection, construction site entrances. All of those practices we see on construction sites to keep the sediment there is what's in the federal permit. And the federal rules do not contain any provisions for post-construction management. So why do we have that in our permit, or how do we have that in our permit? We did that through our state disposal system rules, which is a completely different set of rules we have in Minnesota that kind of gives the agency a pretty broad authority to write rules regarding water quality. And that is the mechanism of which we have our pond requirements inside of our construction stormwater permit. That is a little bit different than you'll see in other states. Some states did it the way we did it. A lot of states have similar requirements, but they exist in state statutes outside of this permit. So there are more than one ways to accomplish this, and there are pros and cons to both, I guess, of having this in the construction stormwater permit. But that's where it is. So how did it get there? Well, I'm going to tell you a little story of how that got into the permit and why it was so different. It was the only one in the country at the time. So yeah, I'll go through this. I wasn't sure if I was going to share this story with you today. I didn't know if it was super interesting, but when I read the content of this bill that was written way back when, it was pretty interesting. So I'll tell you how this went down. Back in the early 90s, stormwater started making the news. People like the Center for Watershed Protection under Tom Schuler were putting out all kinds of publications about urban stormwater runoff and all the problems it was causing. Schuler's work was a little interesting. It was a little bit more watershed based as opposed to just looking at construction sites or individual pieces of property. And other things were happening too in the news. Stormwater was just making a mark. It was getting known. You might have seen a magazine article back then, maybe a blurb on the news, but the word was getting out. Here in Minnesota, in our House of Representatives, we had a gentleman named Leo Redding, and he passed the Redding Bill in 1992. And he wrote that bill with the inspiration from the things that he was hearing in the news about stormwater. The Redding Bill was basically a ponding requirement. I'll tell you about it here in a minute. And that passed in 1992. And right at that time is when we were writing our first construction stormwater permit, and the folks at the Pollution Control Agency decided that we should take what was in this Redding Bill, since it's a stormwater pond, and put it right in the permit. So that's what they did. And there it was in the NPDES permit. We did that under the SDS rules, and we issued that in 1993. It wasn't a very good design in that permit, but it did have some of the key components that I think that you would associate with the modern pond. There was a dead pool storage requirement, there was a live storage requirement, and you had to have a controlled outlet that discharged that live storage at a low rate. So those things were in there. And then shortly after we issued that permit, the Redding Bill was repealed. And I tried to find research on why it was repealed. There were other things in the bill too. I don't know if it had anything to do with stormwater, but nonetheless it was repealed, and we had this requirement in our permit. And that is where it's lived ever since. So like I said, I went back and read this bill. All this happened before my time. In fact, there's nobody of this generation that's left at the Pollution Control Agency anyways, so Mike Findorf from our office and myself were combing through a lot of old emails trying to piece this story together. And we tracked down the bill too. And the bill turned out to be pretty interesting. it had some high-level language that said if you were going to create 1 acre of impervious surface due to your construction project, you had to provide, or you needed to provide a water retention device. It was pretty high level like that. That's kind of what I expected to see in that bill, something at that level. It was pretty long though, and as I read it further, it got pretty interesting, especially the closing paragraph, where it talked about the requirement to have a water management plan, which sounds a lot like a pollution prevention plan that we later required. And look at some of these words that I found. I took this right out of the bill. Utilize the best available technology to minimize off-site stormwater runoff. Maximize overland flow and flow distances over surfaces covered with vegetation. A lot of this stuff is just right out of our modern low-impact development handbooks that you would find. Increasing on-site infiltration, that's the name of the game these days. Replicate pre-development hydrologic conditions nearly as possible. That almost sounds like our MIDS language that we approved in 2009. And encouraging natural filtration functions. I just thought those were some really interesting words, a really forward-looking bill, kind of even above and beyond stormwater ponds, certainly at the time. So that was the Reading bill. And as I said, it got repealed shortly after it was passed. But nonetheless, we had the pond requirement in our permit. So the permits has evolved over time. Ross talks about the evolution of these requirements. They are definitely evolving. In 2003, we fixed some of those sizing volumes that were in there. We got it pretty close to where it is today. We had an additional water quality volume requirement for special waters. The anti-degradation rules were in play at this time and driving a lot of those extra protections around certain waters. Another thing we did in 2003 is we added infiltration and filtration in there as an option, and we didn't have that prior to that. Prior to 2003, if you wanted to build an infiltration system, you really couldn't under the stormwater permit unless you had a pond in addition to your infiltration system, which a lot of people were doing, treatment train sort of approach. So that was very helpful. In 2003, we had a lot more options for people and really kind of moved into the modern day of stormwater management. In 2008, we included impaired waters for that larger water quality volume requirement at 1 inch. And then in 2013 was a drastic change in the way we looked at stormwater. So the permit really changed in 2013. The big change is that we started promoting volume control. And it really kind of was a move away from ponds as the primary source of stormwater management. And all this came to light due to the research we did for the MIDS project. MIDS is an acronym that stands for Minimal Impact Design Standards. And we took a close look. We had a big work group formed at the Pollution Control Agency, and it housed quite a large group of stakeholders. A lot of different voices were in the room for that whole MIDS process, and we met every Friday for 3 years or something like that. A lot of people in the room were here for those meetings. Based on that MIDS work that we did, which I'll talk a little bit more about in a minute here, but it was determined that in order to mimic natural hydrology and get the pollutant reductions that we needed volume reduction, and it needed to be about 1 inch of treatment, that is 1 inch times the impervious surface across your site in order to accomplish this. So in the permit, we moved to a 1 inch standard for all projects, and we really haven't changed the pond sizing criteria since then. So I thought I would just touch on MIDS a little bit. I mentioned it was kind of a move away from ponds, so I wanted to describe what MIDS is and maybe just show you how ponds still fit into the regulatory landscape here, at least as where we're at here today. So what was MIDS? It is design standards, like I said. It was a directive to the agency. This was legislation that was passed in 2009. A directive to the agency to develop standards for stormwater management to promote low-impact development. I took these 3 bullets right out of the legislation. Low impact development means keeping the water on the site such that the rate and the volume of stormwater reaching receiving waters is unchanged. And that rate and volume that we're talking about there is pre-developed conditions, and you're supposed to assume native soil and vegetation. So a little bit different than just pre-construction. We were looking at pre-settlement. What did this piece of property, how did this behave when it was a prairie or a forest versus how it's behaving now that you put an apartment building there or whatever it is that you built? So that was the research that we did and the comparison that we did in order to figure out how much water one would need to hold on the site in order to accomplish these things. Yeah, and that number came out to 1.1 inches, as many of you know, and we kept our permit at 1 inch. Those are pretty close to the same, but that is about the standard. That is what MIDS determined. If you could capture and retain on site 1.1 inches times that impervious surface, you would be on an average annual basis approximately mimicking the natural hydrology and natural pollutant loads. And we analyzed specifically phosphorus to determine that when I'm saying pollutant loads. So in order to accomplish that, stormwater ponds generally don't infiltrate very much. At least we don't count on it when we're designing these things. So simply ponds alone were not going to accomplish this. And it kind of came to everyone's realization that if we were going to try and get these pollutant loads down and try and develop in a way that does mimic natural hydrology and doesn't contribute to water quality problems in the receiving waters, it's going to take volume reduction. And that's about what it's going to be, 1.1 inches on your site. So it was definitely a move away from stormwater ponds. So what does this mean? Ponds are great at removing total suspended solids and other particulate matters through settling. And there's a lot of pollutants that are associated with particles that also will drop out in the ponds. But generally speaking, the dissolved components of these pollutants, and there's a lot of those, are passing right through the ponds. And it has become evident that ponding alone is not going to get us down to these natural levels. So both the MS4 permit and the construction stormwater permit now have a water quality volume that needs to be retained on site. That's if conditions for infiltration will allow. And we do have a lot of sites and a lot of properties across the state where infiltration is really not a good idea or maybe not even feasible. So when conditions are not favorable, such as high groundwater, contamination, or if you're located in a drinking water supply management area, there's a lot of places where maybe infiltration is not such a good idea, and ponds are still our best option there. Although we're trying a lot of different things, and trying a lot of different things that are combinations of things that may or may not include a pond, but they still have a place and they still get used, especially in some of these problem areas. And there's lots of other reasons for ponds too. They're still the favorite for rate control. You can use them for pre-treatment in front of other things. Within a reuse system, you're going to need a pond. As part of a treatment train, there's all sorts of reasons why we're still going to have stormwater ponds here in Minnesota. So in the construction stormwater permit, I won't spend a lot of time on this. Today and tomorrow is not supposed to be a design class of any sort, so we're not going to get into any math, but just wanted to spend a little bit of time describing where our pond requirements came from, what we have in the permit. The NERP study gave rise to the Walker ponds, which were very popular in the Twin Cities, and I think even to this day you might find Walker ponds referred to in some people's ordinances. The Walker pond was based on the idea that you would have a large permanent pool, which the NERP study showed was pretty good for phosphorus removal, amongst other things. And you would size that for a 2-year, 24-hour storm and have a big permanent pool in this pond. That's not exactly our requirement in the construction permit, but that's the concept, and we have a large dead pool requirement. There was another gentleman by the name of Dr. Pitt from the University of Alabama who also put out some studies. I don't think this was his idea, but he studied the effects of having a bounce in the pond, where you capture a certain amount of volume on top of that dead storage, and then you discharge it slowly through a controlled orifice or weir or something like that. Just that little outlet modification really greatly enhanced the performance of these things. And as I said, we have the live storage requirement for our pond as well, and that's kind of where that came from. So it's a combination of those two things. So I was going to close today with just kind of a fun slide to talk about the ancillary benefits of ponds. I think we've already heard a couple of stories, and you all know that these ponds have become amenities over the years. They didn't start out that way. I think a lot of people were rather annoyed by our regulations at the beginning. David's going to speak next from a consultant's point of view, who was designing these things back in the day and trying to explain to his clients why they need these things, and they weren't always it wasn't always well received. So the ancillary benefits, I mean, people are doing all sorts of stuff with their stormwater ponds. There's some real world benefits to these things. You can control erosion and channel protection downstream with these ponds. If you have a sensitive ravine or something, a pond could certainly be helpful for that sort of thing. I said there's no infiltration in ponds. That's not exactly true. They all infiltrate a little bit. Sometimes they infiltrate a lot. I'm sure you've experienced this sometimes. It's hard to get water to stay in a pond in certain areas. Generally they stay full, but it can be an important component for groundwater recharge. Aesthetics, of course, is a thing too. I think the old stormwater ponds in the old days were often tucked in the back corner of the development or behind the building. You don't see that as much anymore. They're often front and center, and they have been turned into a piece of the design. Recreation is happening. We don't really promote this. We certainly don't promote swimming in stormwater ponds, but we do see that from time to time. Wildlife habitat too. Ponds definitely attract wildlife. Not everyone considers that to be a benefit in all cases, but some people do. Fishing. People have stocked their stormwater ponds with fish. You're not supposed to do that, and we don't recommend it, but it's been done. A lot of the old stormwater ponds are often right next to a creek, and due to a flood or something like that, they end up with fish in them. I know that happened to the pond behind my mom's house. There is a creek nearby. It's not connected to it, but I know that it flooded at one point, and it's filled with fish now. And the last one I had on here was water skiing. That picture on the right there is a trophy